Welcome to this session on food preservation. As common people, we know a lot about food preservation because these are processes that we have used very often at home. But we must also remember that this has industrial uses, commercial uses. It is in fact a very, very important area. You must have read many times that we have so much of food production, but because of the processes of spoilage, what happens is that a large proportion of this is lost. The same process takes place at home as well, and we know that we have to throw away many foods because they are getting spoiled. So this is a topic that is of great interest to all of us. So let us begin by looking at the processes involved and what we can really understand from the basic principles. The first principle that we can really talk about is kill microorganisms or destroy natural enzymes. Now what exactly are we meaning by this? That is, we have the basic principle that if we kill the microorganisms, which as you probably know are the cause of spoilage, then we can reduce the process of spoilage and preserve the foods better. So that is one type of aspect. The other type of aspect that we need to look at is the natural enzymes. Now what do we mean by natural enzymes? This means that the foods which are present already in the enzymes which are already present in the foods, these are going to create certain types of chemical reactions, and these chemical reactions are going to lead to changes in texture or flavor, and they are going to contribute to the process of spoilage. So killing microorganisms, which we all know is the cause of food spoilage, that is one part of the story. The other part is destroying the natural enzymes. The second part of the aspects of principles is, if we come back to the visual, we are talking about inactivation. Can we have the slide where it talks about the inactivation of these microorganisms or the natural enzymes? So again we have these two aspects being illustrated, that is microorganisms being inactivated and the natural enzymes being inactivated. So again let us spend a few seconds on what do we mean by inactivation. How is it different really from killing the organism or destroying the enzyme? So inactivation is a process whereby we are not killing the organism, or the enzyme is not totally destroyed. It is still present in the food, but at the same time it is slowed in its action, or it is rendered in such a form that we are not able to use it, or we are not able to employ it in the same way, but the enzyme or the microorganism is inactive, or rather passive. It may be present, it may be in the form in which it can become active later. So inactivation is quite different from killing or destroying. Now if we come back to the slide, we are going to talk about the third aspect, which is basically controlling the factors responsible for food spoilage. Now what are these factors? We all know that there are factors such as the presence of moisture. That is one very important factor. Of course, you must remember that when we are talking about these factors, they are also linked to the process of killing microorganisms, of destroying the natural enzymes, of inactivating. So all these are linked processes, but we must remember that factors such as temperature, such as pH, such as moisture or water activity, these are all factors that we can control. The composition of the gases surrounding the food in storage. So many of these types of factors have been usefully employed by restricting their influence or by controlling their influence so that the food is not spoiled. Now if we look at the next kind of aspect, that is in terms of what are the principles in terms of the processes that we can employ in food preservation. There are two types of things that we can do. Either we can prevent decomposition or we can delay decomposition. So prevention or delay of decomposition. Here again we have the two different aspects, that is prevention or delay of decomposition by microorganisms and prevention or delay of self-decomposition of food by the enzymes. Now this is again an aspect that we can reflect on for a short time. That is, we are talking about decomposition and we are talking about self-decomposition. Now what do we mean by this? Now decomposition is of course by a factor which is external, and we are talking about say microorganisms which are outside of the food but which enter the food and cause some types of changes. and which cause the spoilage to take place. The enzymes, on the other hand, are already present in the food. So this is a kind of self-decomposition. It is a component of food itself which is causing it to spoil, and therefore we are calling it self-decomposition. So now that exposed you to two different types of processes, prevention and delay. Now if we move on to the next slide, we are going to have a look at some of the methods by which we can preserve foods. How do we tackle microbial decomposition? As we already told you, these are things that can be controlled and that they can create conditions for the microorganisms' growth to be controlled. So let us look at these very briefly. High temperatures, low temperatures, drying and acids. So let me just give you a little orientation to these particular ways of tackling microbial decomposition. The first, as we all know, is basically the use of temperature. If we have high temperature, we know that microorganisms are either inactivated. If the temperature is high enough for a long enough time, we know that the microorganisms can be killed. So this is basically, in essence, what high temperature does. Low temperature may not be as effective as high temperature. In fact, some of the microorganisms may continue to be present in the food even with severe freezing. What happens is they get inactivated, they don't get killed. So this is again a difference between the use of high temperature and the use of low temperature. We are of course going to, in a short while, talk about these in a little more detail. So we have talked about the processes of using low and high temperatures. Now let us talk about the process of drying. We are all very familiar with this process. We have seen the use of the sun, for example, for drying foods at home. It may be fruits, it may be items such as papads, it may be lime, it may be any of these types of items which we have observed being sun dried. There are other commercial and industrial processes of drying which we will talk about a little later. But this is another kind of a method that we need to look at in detail. Again, in the case of drying, what happens is that the microorganisms are not necessarily killed. They are usually inactivated. And the reason for this is that the water that is present in the microorganisms is usually very high, the proportion of water, and the moment this water is removed, they cannot grow and they cannot function as they normally would. So in effect, what happens is that activity is curtailed, the food spoils slower, and we have a process of food preservation. Now the fourth one that slide talked about is basically the use of acids. Now what do we mean by acids? Here again we have acidic foods, we all know, which taste sour. For example, lemon or orange, tomatoes. These are all foods that naturally contain acids. And it's very interesting to see that some of these foods, if the proportion of acid is high enough, don't spoil as easily as foods which have low acid content. The reason is that microorganisms don't like acid. They will not grow, they will not function properly, and if the acid is combined with something like high temperature, as we will see in a subsequent discussion, if the combination is there, then the microorganisms are often killed or severely inactivated. So this is something that we need to keep in mind. Now let us have a brief look at some of the other types of ways in which we can tackle microbial decomposition. If we look at the next slide, this is basically sugar and salt in high concentration. This is again something that we use very often at home also. It is also employed in the industrial settings in preparing commercial foods. Then we also have factors such as smoke. I don't know whether you have come across, I'm sure you have, for example, meats and fish. Smoking is a process, or smoked foods are a way in which the foods can be preserved. Now how does smoking actually preserve food? There are 2-3 factors or combination of factors happening there. One is the application of heat. We know that smoking is over a wood fire, so there is heat that is being transferred to the food, and this temperature rise is causing the inactivation or death of the microorganisms. In addition to that, when the smoke comes in contact with the food, there are certain types of chemicals that are getting added to the foods. For example, you may have chemicals such as formaldehyde. We all know that's a common chemical which is discussed in the preservation of items, and it is applicable here also. We have other components. One of them which is can be very dangerous is when you add certain salts, certain compounds such as sodium nitrite to foods in order to enable the smoking process, in order to improve the flavor. These can be very effective as far as smoking and preservation is concerned, but at the same time in the food they can cause some harmful changes. What happens is that the nitrites get converted into compounds which are called nitrosamines, and these have been shown to be cancer causing. So we have on the one hand beneficial effects of certain processes, on the other hand we have detrimental or harmful effects of the same processes. So actually what we have to do is to create a balance to optimally process the foods so that we have the maximum nutrient value, the maximum taste, the maximum flavor, and the maximum retention of the structure of the food. At the same time we have the control of the factors which are responsible for spoilage. We have killing or inactivation of the microorganisms, and we also have the processes of inactivation of the enzymes or destruction of the enzymes. Now if we come back to the slide, we have a couple of other methods that are mentioned there. We have removal of air, chemicals, and radiation. So let us just spend a minute or so talking about these three aspects. Now removal of air. What do we understand by that? Suppose we are removing the air from the surroundings of the food. What do you think will happen? We all know that oxygen is a gas that is very essential for life. You cannot imagine any metabolism taking place without oxygen. So what is happening is that when we remove air, we are also removing the oxygen that is present in the air. So what happens is that the microorganisms, they are not getting the oxygen that they need for their growth and functioning and activity. The enzymes which are present in the food are also deprived of the oxygen. So as a result you have the slowing down of the chemical reactions, you have the slowing down of the growth of the microorganisms, and the result is basically that we are able to preserve the food. This is also a very developed area in food processing now. Of course, since we are only talking about food preservation, we won't go into so much detail, but you must remember that there are certain organisms which in fact like the absence of air or the absence of oxygen. So you have to be very careful when you use this method also, that you are not, while inhibiting the growth of the aerobes, that means the organisms that like oxygen and air, we are not facilitating the growth of the anaerobes. That is those organisms which like the absence of air or the absence of oxygen. Just imagine the diversity in life, that you have such a factor. At the same time you are having organisms that can grow very well in the absence of oxygen. You have other organisms that cannot grow at all without oxygen, and then there are some types of organisms which are called the microaerophiles, which can grow with very little or small amounts of oxygen. If the amounts increase, they are again not able to grow in such an atmosphere. So we can see that all these require careful control and careful attention. Otherwise you can have the situation where in trying to control one type of organism, you are actually helping the growth of another type of organism. Now the last factor that we had really mentioned over there is radiation. You must have heard of the use of radiation. It is started in India also, but quite common in the West, to prevent processes like sprouting, say in potatoes or in onions. You have this process by which the sprouting process is stopped. You know that when these sprout, then it leads to softening of the onions or the potatoes. It leads to certain processes of spoilage. So this is one way that is used. Of course, radiation can kill microorganisms straight away. It is one of the very effective ways of killing. But again we have concerns there about what is the effect of this ionizing radiation, say gamma rays or X-rays or electrons. What is the effect of these on the food itself? Are they causing harmful chemicals or compounds to be created? This is something that is undergoing a lot of research, and we are also seriously exploring this option in India, but we have a need for a lot of research into some of these aspects. Now let us move on to the next really aspect that we need to look at in terms of the specific methods. Now if we look at the slide, we are starting with the use of high temperature. Now what exactly happens here is that most bacteria, yeasts and molds, what is happening is that they like a certain range of temperature. For example, 16 degrees to 38 degrees. That is the temperature at which they feel most happy. They grow rapidly, and what happens is the loss of the quality of food, the spoilage takes place, and it can be quite dangerous also, because some of these microorganisms are in fact disease causing, or they are pathogens. So in that case we need to be very, very careful in controlling them. So that is one particular aspect. And what are the kind of temperatures that will kill them or will really inactivate them? Again, we have a temperature range, if we come back to the slide, between 82 to 93 degrees centigrade. So we know that between 16 to 38 degrees centigrade, they grow quite well, they grow best in that temperature range. But at the same time, most bacteria are killed in the range of 82 to 93 degrees centigrade. Now, did you notice a difference between these 2 points? In the first one, we are mentioning bacteria, yeasts as well as molds, all three. And we are saying that they grow best in that kind of a temperature range. But in the second aspect, what we are talking about is that we are only talking about bacteria. And we are saying that the bacteria are killed in that range that we talked about, basically 82 to 93 degrees centigrade. So we have a difference right there between bacteria and between yeasts and molds. And what is the conclusion that you have come upon after looking at that aspect? That is basically that bacteria are more sensitive to heat, that they are easier to kill than say yeasts and molds, which may tolerate higher temperatures. Now if we look at the next particular aspect about use of high heat, that is higher temperatures at high pressure are required to destroy bacterial spores. Acid increases the killing power of heat. This is of course an aspect that we talked about earlier also. Combination of acid and heat can be very, very detrimental. It can actually kill the organisms. Pasteurization. We all know that pasteurization is a process commonly used for milk. That is a process that is used to preserve milk and more importantly to kill the disease-producing organisms. Now what do we mean by that? For example, the bacterium that causes tuberculosis. When the cattle have tuberculosis, that gets passed on to the milk. So what is happening is basically we are using the process of pasteurization to kill the disease-producing organism, in this case the organism that causes tuberculosis. So pasteurization is basically use of heat, but use of heat in a controlled fashion. You can have a larger duration and a lesser temperature, or you can have a higher temperature with a short time. In fact, that is now called HTST, or high temperature short time processing, which is now commonly used when milk is commercially processed. And it is very effective. In fact, the pouches of milk that we get are all pasteurized. And the reason is because all those germs or organisms that are passed on by the cattle to the human beings, through the milk, we can control them, we can kill them by this very simple process. Now again, when we look at some processes like pasteurization, we need to reflect on the fact that any use of high temperature also changes the quality of foods. For example, there may be change in consistency, there may be change in texture, there may be change in the flavor. Now we all know condensed milk is different from the pasteurized milk because it is subjected to high temperatures for a longer duration of time. So you have a difference in their very nature, their color, their flavor, their processing. So you have this kind of balance that has to be maintained all the time between the quality of the food, the flavor, the color, the texture, and the point that we are trying to achieve, that is we are trying to control the growth of the microorganisms. Now if we look at the contrast with the use of low temperatures. The growth of most microorganisms is slow at temperatures below 10 degrees centigrade. And cold cannot be depended on to destroy all bacteria, even severe freezing. Now if we look at the difference between low temperature and high temperature. A little while back we had talked about the difference between the two. We had said that low temperature is not that effective in killing off the microorganisms. So what you are seeing here is that if the temperature is below 10 degrees centigrade, the growth becomes slow. And also very, very important that we cannot depend on cold to destroy all bacteria. Even severe freezing, we find, cannot kill all the bacteria. It may kill some of the bacteria, but it will not kill all of the bacteria. In fact, very interestingly, there are bacteria which absolutely love colder temperatures. They are in fact very, very evolved organisms in that way. You have such a range of the conditions in which they can grow. If you are using a particular factor such as temperature, you need to know that there are some which will survive in higher temperatures, there are some which will survive in the lower temperatures. On the other hand, you have some that will be killed by this kind of processing. So this is something that we need to keep in mind, particularly if we are trying to sterilize the food. That is, if we are trying to kill all the microorganisms, we may not be able to do so with just a single process. For example, when we were talking about bacterial spores, we said in the case of heating that we need to apply high temperature and high pressure. So this is a combination of factors, and we are using it to kill the microorganisms. Now let us again talk about some of the other aspects that are involved in the use of low temperatures. If we have the next slide, cold storage and freezing do not sterilize foods. Cold storage and freezing do not sterilize foods. In other words, they do not remove or kill all the microorganisms. And the second aspect that we are talking about here is basically when frozen food is thawed, the surviving organisms start growing very rapidly. Now what does this mean? What is thawing? What is exactly sterilization? Let us just spend a little while talking about these aspects. Now sterilization, as you all know probably, is the process by which all organisms are killed in the food. In other words, the organisms are all free. The food becomes free from the organisms, or all the organisms are killed. So that is what we mean when we say that cold storage or freezing, that is not going to result in sterilization. And the second aspect was basically the influence of thawing. We said that if suppose a food is frozen, the microorganisms and the enzymes, etc., they all become inactive. The moment the food is thawed, the bacteria may start growing even more rapidly than they were doing originally. So this is a great difference that we find. When we bring the temperatures from freezing temperatures to room temperature, that is what we mean by the process of thawing, the bacteria are growing more rapidly. Now that creates the question in our mind, why is that happening? Why are the bacteria actually growing more rapidly? The reason is that when freezing or cold is applied to a food, the structure of the food also changes. The cell walls may break down, they may get disrupted, so it may actually become easier for the bacteria to attack the food, and therefore, because they have more availability of the substrate or the nutrients in the food, they become even more happy and they start growing more rapidly. So this is a kind of a best environment for them once the food comes down to room temperature. This is very common, like for example, you buy a packet of frozen peas and you put it in the freezer in the fridge, for example, and then you take it out and you use about half the packet, and then you leave it lying, and then if you feel like, you put it back into the fridge, and you are assuming in your mind that spoilage is not going to take place because it was frozen when you bought it and you had put it in the freezer. But what has happened is that when you thawed it at least slightly to use half of the packet, the rest of the packet is thawing. There is a process of coming slowly to the room temperature, and the bacteria which are present still may start growing once again. Of course, in commercial processing, they do take care of that to some extent by blanching the food before it is processed. What is blanching? Basically exposure to heat for a very short time by immersing in steam or in hot water. So very quickly they are removed from that and then they are frozen. So actually they are quite safe in that respect, but that doesn't mean that we don't have to be careful when we are using such foods, particularly if we are not emptying the entire packet. Now if we come on to the next visual, and that is going to tell us more about another method of food preservation, and here we are going to talk about the use of drying. Now when we remove water from the food, what is happening? Removing water from the food will bring bacterial multiplication to a stop. In other words, the bacteria are going to stop growing, they are going to stop multiplying. Again, like in the use of low temperatures, what we are saying in the second point is that drying does not cause destruction of all microorganisms. Drying does not cause destruction of all microorganisms, so you cannot use it really for sterilization. As we know, sterilization is the process by which all microorganisms are killed in the food. Now, when we talked about the first point, that is basically the removal of water, we need to remember that microorganisms are nearly 80% water. Their tissues are composed nearly 80% water. So when we remove the water, what is happening is that their metabolism, their processes of growth, all this gets slowed down and stopped, and therefore we don't have the situation where the microorganisms are growing. And if they are not growing, they are not going to contribute to a fast spoilage of food. So what we have done is we have retarded the process of spoilage, and therefore we have preserved the food. In fact, as I was mentioning earlier also, this is a very commonly used process, both at home as well as in the commercial settings, and dried foods are very commonly available in various forms. Again, we have an area of concern here that sometimes fruits, for example, they are treated with compounds called sulfites before drying. These have been shown to cause severe allergies, particularly in young children, in sensitive individuals. So we need to keep an eye out not only on the process or the optimal use of the process, but also the use of certain chemicals. In this case, we were talking about the use of sulfites. If you remember earlier, we had talked about the use of nitrites in the smoked foods. So we have to be very careful in the type of processes that we use, in the type of additives that get added to the food, and the type of durations or the length of time that we are using these processes. Just like in the case of freezing, in the case of drying also, commercially there are various types of processes that might be used. For example, in the case of freezing, say in the case of ice cream, we all know that we would like to use the process of getting the food frozen, but at the same time we don't want to crunch into large ice crystals in the ice cream. So commercially what is done is that the mixture is applied onto a very cold surface and scraped off immediately. So the very low temperature makes the food freeze, but the time and conditions are not good for producing the ice crystals. In other words, the moisture that is there in the ice cream mixture does not crystallize into the ice. The water does not become ice, so you get very, very tiny formation of crystals, and that does not, we cannot feel it when we have the ice cream. So that is one kind of process. We also have other types of interesting processes. For example, freeze drying. This is a combination really, where the food is placed, the frozen food is placed in an atmosphere where the frozen water in the food directly gets converted into water vapor. This is called the process of sublimation, directly from solid ice to gaseous water vapor. So this is another process by which the drying can take place, that you remove the water from the food and you're using the process of freezing to do it. At that very low temperature, this process of sublimation takes place. You have various other types of very interesting types of processes which have been developed, but that would be going more into the areas of food processing, which we will talk about in another session with you. So right now let us come back to talking about the next aspect, which is about drying itself. If we come to the next slide, while bacteria will not grow in dried food, the moment moisture is added, bacteria start growing. And here again we have the contrast between bacteria and molds, that molds can grow even on semi-dry foods, which is not possible in the case of bacteria. So let us spend just a few seconds on this, that bacteria will not grow in dried foods. It means that they will not be favored, their growth will not be favored by the presence of the drying presence or the absence of moisture in the food. But on the other hand, when we add the moisture, they will start growing. This is something like we talked about in the process of freezing as well, that as long as they are frozen, they remain inactive. The moment we thaw the food, they again become very active. So in the case of the drying also, when the water is removed from the food, as in the process of dehydration or drying, the bacteria become inactive. But when we rehydrate the foods, or we start adding the bacteria, adding the water to the food to rehydrate it, the bacteria start growing again, and they can start growing quite rapidly. So this is one kind of aspect. And then what we were talking about, differentiating between the bacteria and the molds. Molds or fungi, as you know, can grow on semi-dried foods. For example, you have kept some fruits out in the sun, you have dried it, but they have not got thoroughly dried. They remain having partial amounts of water in it. So what really happens there? That you find after some time that there is a layer of fungus or some molds have started growing on such food items. So you find that molds have a greater tolerance. When you remove the moisture, bacteria are again more sensitive, just like we found in the case of temperatures. Any organism that causes spores can be very, very resistant, because these spores are meant to protect the organism. They have certain sheets or coverings which are very resistant to microbial action, to the action of other factors such as moisture, such as the content of oxygen in the air, and various other such factors. So any spores that are present will continue to be active if they get the right conditions. So the moment they get enough water, the moment they get enough of a proper atmosphere for growth, they will immediately start growing. So the case of fungal spores, the case of bacterial spores is quite different from the organism itself. The organism may be quite sensitive, but the spores are usually resistant. The reason is that the spores are actually created by the organisms for this very purpose. The organism wants to survive, and therefore it creates the spores, and the spores will continue to survive in very inhospitable kind of environments. Now let us look at the next aspect which we have touched on earlier also, and that is the use of acids. Microorganisms are sensitive to acid. Now we have repeated that many times, and that is the reason why certain types of foods, for example fruit juices or tomato puree or tomato juice, some of these types of foods are not so easily spoiled as, say, milk, which is a low acid food. In fact, we know that milk is so low acid that if we just squeeze a little bit of lemon or there's a slight growth of microorganisms, the milk will curdle, because the pH balance is so finely maintained, and milk in that form will not exist in the presence of acid. So milk spoils much faster than, say, a food that is like, say, tomato juice or tomato soup, which has a higher amount of acid in it. So the higher the acid content, the less the chances of the food spoiling. So that is one kind of aspect. Now if we come back to the slide, let us talk about the acid which is produced during certain processes. For example, we have fermentation. If we look at the slide, we have a process whereby we create acids in foods. For example, when we are fermenting certain foods, there is an automatic production of acids in that food. So these acids in such a situation will inhibit the growth of the microorganisms. So let us just spend a few minutes on talking about fermentation itself. Now what is fermentation? Are you aware of some fermented foods? Are you familiar with the use of fermentation? I'm sure you are, because you have had foods such as dhokla, such as dosa and idli. These are all basically fermented foods. So what is happening is that a certain substrate in that food gets acted on. And what is acting on those foods or those substrates? It is very interesting that we are actually using microorganisms to stimulate this process of fermentation. And what happens is that this process can curtail the growth of undesirable organisms. So we have, for example, when we convert milk, say, into curd. We'll talk about that in a second. When we convert milk into curd, what is happening is that certain bacteria grow, the bacteria which are responsible for this process, in fact, they grow and they survive, but as they produce the acid that is responsible for the sourness in the curd, as more and more acid is produced, other microorganisms start getting killed off. So the conditions are no longer favorable for all types of organisms. So you have, in a way, you are also protecting people who are consuming that food, because the type of organisms are limited, the pathogens tend to be destroyed. Now if we have the next slide, let us talk a little bit more about the use of acids. Here we are talking about acids being added to beverages like carbonated drinks, or they may be produced in foods such as curd. So what does this mean actually? If we can add acids from the outside, that means we are actually adding acids to the food, or if we are producing them in foods. So we talked about both these aspects, and we said that in the case of curd, we are producing acid by a certain process. In certain other foods, we are actually adding acid. Carbonated drinks are of course like the soft drinks that we are familiar with, that we have consumed at some time or the other. They are in fact highly acidic. Just as an aside, you may have heard of certain types of research which show that these acids which are produced in the carbonated drinks or added to the drinks, they can actually harm our teeth. So it can result in a process whereby dental decay or tooth decay is taking place because of these very acids which are present in the food. And also we need to remember that the degree of preservation, that depends on various types of factors. Do you remember one type of factor? That is when we are combining acids with what else? If we are adding acids to heat, remember we talked about that acid increases the killing power of heat. Similarly, heat application increases the killing power of acids. So this particular combination can be very, very effective. So in that case, what will happen? The preservative effect is much larger than if we were just using another process whereby only acid or only heat is applied. Even in the use of acid, the type of acid, the extent of exposure to the acid, the duration of exposure, whether it is already present in the food, whether we are applying certain other processing methodologies, all this will influence the actual effect of the acid. So far we have looked at a range of factors really. We have looked at temperature, we have looked at acids, we have looked at drying. Now let us move on to another very essential aspect which we all are commonly using at home also, and that is the use of sugar and salt. Now when microorganisms are put in a heavy sugar syrup or in strong salt water, the water from inside the cells moves out into the concentrated syrup, causing partial dehydration of the cells. So what is happening here? This is actually what is called the process of osmosis. I'm sure you have learnt about this process. What is happening is that we are putting the microorganisms in a concentrated solution. It may be salt, it may be sugar. Now what is the influence of this? Because of osmosis, the water from inside the bacterial cells is going to move across the cell membrane into the solution outside. So what is going to happen inside the cells? Again, it's a process of removal of water. And what did we say earlier about removal of water? We said that when we remove the water from the cells, they are not able to function properly, multiplication stops, growth stops, the activity and functioning of the cells stop. So what happens is that there is an effect of preservation in this case. We know that in the production of jams, jellies, marmalades, in the production of pickles, these are all very commonly used. In fact, if you look at pickles, you will notice that pickles, there is a combination of factors also. We are drying some of the items sometimes, we are adding a lot of salt, so that has a preservative effect. And if you notice in pickles, we are also leaving an air layer, an air barrier on top of the pickle, and that is an oil layer. So the air cannot penetrate, so again you have an effect of preservation. So that's also a very interesting aspect, how very often even at home we are not using a single process but several types of processes to retard the spoilage and to preserve the foods better. So this is something that is very important that we are using when we are using sugar and salt. So now let us look at some of the other aspects in the next slide. And basically what we are saying in the next slide is that we are interfering with the growth and multiplication of the microorganisms. And the yeasts and molds are, again, there is a difference between yeasts and molds as compared to bacteria. Yeasts and molds are more resistant. Bacteria are less resistant. They are more sensitive to this kind of manipulation. So can we have the slide just to look at the aspects that we have just talked about? Use of sugar and salt. This interferes with the growth and multiplication of microorganisms, and yeasts and molds can tolerate dehydration much more than bacteria can. So this is comprehensively something that we studied in addition to drying, in addition to acid, low and high temperatures. Now we have talked about the use of sugar and salt in high concentration. Now let us briefly touch on some other aspects, especially the use of these principles in home scale food preservation. If we have the next slide, what we are talking about is drying, pickling, sugar and chemicals. So we've just touched on 4 types of ways in which home scale food preservation is done. Drying we're very familiar with at home also, because we have talked about in terms of the removal of water, in terms of removing any chances that the food will become moist or will have some kind of access to moisture, and this will result in a process of spoilage. Pickling we had again talked about. We said that there is a combination whereby the pickling is using oil, it is using the processes related to drying sometimes, it is using salt in high concentrations. The third type of aspect, if we just briefly return to the slide, that was in linking the processes to the addition of sugar. We know we have marmalades, or we have jams, we have jellies. These are all food products in which we are using a lot of sugar. Again, what is the process? Because of the process of osmosis, the water is removed from inside the microbial cells, and we are having a much more favorable environment for preserving the food rather than spoiling the food. And the last one was, of course, when we talked about chemicals. There are various types of chemicals also that we use commercially. Of course, we have talked about some aspects, but there are preservatives that we can add to foods which are commonly used. And these preservatives also used in very particular small amounts, so that we have a kind of a preservation of the food without losing out on the taste or the color or the flavor. Again, when we talked about the chemicals, we need to keep their health effects in mind. We cannot use them freely. For example, chemicals we know can kill microorganisms, but does that mean that we can use all the type of chemicals that are used for such a purpose? No, because they are not all safe for human consumption. Some of them in fact can be very, very dangerous. So we need to use them, only the permitted chemicals, and the chemicals in small enough amounts, permitted for use and permitted in the amounts that are permitted, not any more than that. Sometimes we feel more the merrier, so we start adding more of these chemicals, but that can be very harmful. And now just briefly touching on one process, that is canning. We are all familiar with canning and aseptic packaging, where you have seen these cartons of milk, we have seen various types of canned foods. These are also processes that are now coming up in a big way. In canning there is use of heat, and we are heating the food as well as the can together, and we are removing the air. In the case of aseptic packaging, we are modifying the atmosphere, and we can use materials such as plastics which are completely destroyed in the presence of heat. So we have covered a lot of ground. We have talked about commercial and we have talked about home scale preservation. You must look into all these aspects when you select foods and when you decide on how you use these preservation methods at home. So we hope that that has been a really interesting exposure to this area, and we hope that you will look more into your materials and study more about this very useful and interesting aspect. Thank you.